Alright, time to go back to work. Today we're going to talk about box and whisker plots, which of course means putting cats into boxes. Or maybe not. This section includes a lot of vocabulary, and you're going to need to take a lot of notes. So I recommend taking out paper, pencil, and getting ready for a lot of information. Let's get started. Alright, so first thing you want to know about box and whisker plots is what a measure of variation is. So let's talk about some of this vocab coming up here. And so if you have a textbook and you have it with you, go to page 461. I'm looking at the left-hand side here with all the vocab. You have to know all this stuff if you're going to be able to do a box and whisker plot correctly. So because there's a lot of questions I'm going to ask you with regards to the box and whisker plot. So first things first, measure of variation, as I was saying. A measure of variation is a measure that describes how spread out or scattered a set of data is. So basically what we're going to do is we're going to graph a whole bunch of data and see what's spread out and what's over here, and we're going to take and analyze sort of the data. So a measure of variation is just analyzing the spread of your data, and that'll make more sense later on. So the first thing I want you to write down is what's on this page right here, focusing more on this at first, and then I'll reference this a little bit later on. This is an example of a box and whisker plot. And I already feel the need to move things around, so there we go, that's much better now. Now I'm referring to these vocab words in the book. Starting with range. What does the word range mean here? Well, the range is the highest value and the lowest value taken away from the highest value. So, for example, the range here would simply be taking 100 and subtracting the lowest value, the lower extreme, which is 60, which of course is right here. The lowest number is 60, the highest number is 100. Even though there's more ticks over here, there's no value over here. The last one is here, so 100 minus 60 is going to be 40. So the range is 40. So far so good, no big deal with the range. Let's go to the next one, the quartiles. Well, looking at the screen here, the lower quartile is right here. We call that the LQ, sometimes also referred to as, depending on what book you're reading, is Q1. So this we call, I'll just make a little note to myself or to you as well, Q1 or quartile 1. That's a Q1. Then we have an upper quartile, which is right here. We call that Q3. Okay, oops, that's a 2. Q3. Then there's the median, which, let me not get ahead of myself here. After quartile 1, what else we have here? Measure of variation, quartiles, lower quartile, upper quartile. Oh, the interquartile range. The interquartile range is from here, Q1, all the way up to Q3. So it's, don't get this confused with range. Range, of course, we did was 40. The interquartile range is the Q3 minus the Q1. So it's going to be 90 minus, looks to be about, let's just say for the sake of this, 73. Okay? Usually be more specific with the number, but let's just say for this sake, 90, the interquartile range is 90 minus 73 here. Okay? Interquartile range. And the last word I want to talk about, just real briefly, we're going to come back to these words again when we do the examples. The last word I want to talk about is an outlier or an outlier. Those are usually numbers way beyond the box and whisker plot. You're going to want to exclude those data points. So if you have like a point way out here, this is an outlier, or way out here, there could be 2 outliers. You don't include them because they'll throw off your variation. Okay, so keep this in mind. This is just a starting point. We're now going to go into some examples. You're going to see how this all works. All right, our first example is taken from your textbook on page 464. We're going to go through each of these questions, starting with A, working our way down. So the table shows data about languages spoken in home. And we have the various languages all over here, and the number in millions. So this would be 28.1 million, which actually looks like this. So just so you know, 28.1 million is 28,100,000. Just to throw that out at you to make sure you're aware of what 28.1 million is. I'm going to delete that now. Or not. Anyway, determine the range of the data. Let's start with A here. Determine the range. Well, the range is the highest value and the lowest value. You're going to take the lowest from the highest. So if you look here, the highest number is 28.1, and the lowest value is 0.9. If you go ahead and subtract there, you're going to get 27.2, which actually is the question down here. So what is the range of the data? Number 1, the answer would be 27.2. Okay. That's it. That's the range of the data. Let's move on. Find the median, letter B, find the median in the upper and lower quartiles. Now, once you start doing these questions, the first thing you need to do, especially when you're addressing the median here, is you need to order these numbers, all these numbers here, from least to greatest. So, let's do that. And there you go. So, we now have the data in order from least to greatest. We're now going to find the median here. And if you notice, there are 8 numbers. 1, 2, 3, 4, 5, 6, 7, and 8. That means there's not going to be a true middle. So the middle is going to be 4 up and 4 down, meaning right about here, I'd say. There's your middle, right? 4 this way and 4 this way. So we got to find out what is between 1.2 and 1.4. And you know how to do this, right? We've done this in the previous section. To get the median, you're going to add 1.2 and 1.4 together and then divide by 2. And what you end up getting is 1.3. Let's go ahead and write that in there as the median. 1.3. 1.3. Now here's something interesting. The upper and lower quartiles, what they're asking here, upper and lower quartiles, which if you remember from our picture earlier, I put up here, the lower quartile is this thing right here, the end of the beginning of the box, and the upper quartile is the end of the box. How do you get these values here and here? Well, the lower quartile is simply, listen carefully, the lower quartile is simply going to be the median of this bottom half of data. So once you have your median, the real median is right here, right? The lower quartile is simply going to be the median of the lower half of the data. So we now have our data in half with this being the median. So we have this is the bottom half. All these are the bottom. And what's the median of the bottom half? The median of the bottom half is right here, right? 1, 2, 3, 4 data points. So the median is going to be right here. So I'm going to draw a little line here, a little arrow, and the median of between 1 and 1. What's in between 1 and 1? Well, nothing really, just 1. So you're going to write down 1 is what we call the lower quartile, the LQ. I'll put equals LQ. That's the lower quartile, just like that. Now, the upper quartile, I like to look at the data up here on this half. 1, 2, 3, and 4. What's halfway between? Let's see here. Right here, what's the median of the upper half here? Okay? So between 1.6 and 1.2 basically. So what you'll do is you'll add 1.6 and 1.2, and then you're going to divide by 2. And what you'll get is 1.8. So the median of the upper half of the data is called the upper quartile. Kind of makes sense actually to think about it now. I'll write it as equals upper quartile, or UQ. That's your upper quartile, UQ. So that takes care of B. Let's move on to C now, which says, what is the interquartile range? Well, I want to graph this box and whisker plot and then discuss the interquartile range, which again is this range from here to here. If you remember earlier, It's from here into here. Inside the box is the interquartile range. Don't confuse that with the real range. The real range is from where to where? The real range, the range, we'll just say, is from here to here. The interquartile range is here and here. So let's do that now. Okay, so the first thing I'm going to put down here is lower quartile, which is down here. I'll put my little line. This is going to be a little sketch of a box and whisker plot. It's not going to be perfect. There's the lower quartile. Here's the upper quartile. And the median is right here. Just for the sake of this example, I'm going to make it all sort of evenly spaced, but it won't actually be evenly spaced if you have the number line like here. So if that doesn't make sense to you now, don't worry about it. I just want to give you a little sketch. This is just a quick sketch. So I'm going to just make a little box here, like so. Of course, we're interpreting this as, this is my median. This is my lower quartile, which is 1. This is my upper quartile, which is 1.8. In the interquartile range, we're going to take 1.8 and subtract 1. Interquartile range is the box, inside the box. So 1.8 is the high, minus 1 is going to be an interquartile range of 0.8. So the interquartile range is going to be 0.8. I just wanted a clean screen here for these last few questions here. Identify any outliers. If you look closely here, Spanish is really an outlier, but you're not going to exclude this from the data because these are different languages, and you can't just exclude Spanish as a language, even though it's clearly the dominant language here of these languages. So it is an outlier, but we're going to keep it in the data for this example. There will be circumstances where we exclude outliers, but not in this example. Let's take a look at E now. And he just wants you to basically describe what's going on with this data here. If you look closely here, that meeting that we got earlier was a good description of what's happening with this data. I believe the median was like 1.3, right? And we had upper quartile of 1.8, a lower quartile of 1. Ultimately, that's where most of your data is, right in this region right here. So in describing this data, the median is a good identifier here of what's happening with the data. I would not use the mean. The mean would make everybody seem like it would not really. This raises the average so much that the mean would not be something you'd use here. But the median is a good predictor, or a good. It'd be a good descriptor, I should say, of the data. All right, that concludes this lesson. I'm going to do another one, and hopefully this comes together the more you watch the videos and the more you take notes. I'll see you in a little bit. Bye.